Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. Now in this video we are going to start the ultimate analysis. So let's get started. Well, the ultimate analysis provides the convenient method for reporting different major organic components present in the coal, or we can say that it helps to find the composition of coal. Well, for this analysis, a sample of coal is being kept in the ultimate analyzer, where we measure different components that are present in the coal. Well, this determination of different components includes the percentage of total carbon, then the percentage of total hydrogen, total nitrogen, total sulfur. Well, this ultimate analysis also determines the ash content of particular coal sample. So, let's start our discussion on the ultimate analysis by the measurement of total nitrogen. Well, the total nitrogen in ultimate gas analysis is the measurement of weight percentage of nitrogen present in the coal sample. Well, nitrogen is mostly found in organic fraction of coal. So, the organic fraction of coal includes the nitrogen. Upon combustion, this nitrogen is liberated and it's in the form of nitrogen oxide. Well, this nitrogen oxide reacts with water vapor present in the atmosphere and produces nitric acid. Well, this nitric acid is environment concern since it ultimately produces acid rain. So, we have to minimize this nitrogen content of coal. So, this was about the measurement of nitrogen. Now, let's move to the second measurement, and that is measurement of total carbon. Well, the carbon in the ultimate analysis is the measurement of weight percentage of total carbon that is being present in the coal sample. Well, fixed carbon from the proximate analysis that we have seen in the previous video, that is completely different value from the total carbon. If you have missed that proximate analysis, you can find that video in the I button. So, the total carbon includes the total organic carbon that is escaped during the combustion reaction in the form of volatile matter. So, the proximate analysis where we measure this carbon percentage does not include carbon present in the volatile matter. While this ultimate analysis, total carbon includes that carbon present in the volatile matter. So, when coal is combusted in combustion, this carbon is liberated as the carbon dioxide or as the different hydrocarbons such as methane, ethane. The total carbon measurement may include carbon from mineral such as CaCO3 as well as organic fraction of coal. So, the total carbon also includes carbon present in minerals such as CaCO3 and different organic materials. So, this was all about the total carbon. Now, let's move to the next measurement, and that is of total hydrogen. Well, the hydrogen in ultimate analysis is the measurement of weight percentage of total hydrogen that is being present in the coal sample. During the combustion reaction, hydrogen is liberated in the form of water vapor, which can come from the organic compound in the coal or inherent moisture that is present in the coal. So, there are two sources of hydrogen. One is the organic compound that is present in the coal itself or the inherent moisture present in the coal. Value of total hydrogen are used to calculate the amount of oxygen needed for the efficient combustion in the boiler. So, the amount of hydrogen tells us the amount of oxygen that will be required for the complete combustion of coal. So, this measurement of hydrogen is very important again. Well, it also tells the material balance in the coal conversion process such as gasification and liquefaction. So, for the material balance point of view, the total hydrogen is again very important, as it informs or it tells about the different processes, that is gasification and liquidification. So this was all about the hydrogen content. Now let's move to the sulfur content. Well, the total sulfur in the ultimate analysis is the measurement of weight percentage of total sulfur that is being present in the coal sample. The test: a coal sample is grounded to set size and weighted, then placed in the sulfur analyzer. So what we do is, we take one coal sample and we reduce its size to particular set size and weight it, and then we place this sample in sulfur analyzer. Well, in this sulfur analyzer, this sample is combusted at temperature around 1370 degrees Celsius in the presence of oxygen. So this oxygen is reacted with sulfur to produce sulfur dioxide. So this sample is combusted in the chemical reaction and it is allowed to react with oxygen in order to produce sulfur dioxide. Now this gas is then passed through an absorber detector in which the analyzer which measures the concentration of sulfur. So the product of this combustion reaction is allowed to pass through one absorber detector where we detect the sulfur compounds or measure the concentration of sulfur. So this is how we can measure the component of sulfur. The total sulfur is important because sulfur combined with oxygen in boiler and it produces sulfur dioxide. Well, this sulfur dioxide is then react with water vapor present in the atmosphere and produce sulfuric acid. This sulfuric acid is again the environment concern because it ultimately produces acid rain. So we have to minimize this sulfur content of fuel. So this was all about the total sulfur content and the ultimate analysis. Well, this ultimate analysis is very important for the exam point of view. It combinedly with proximate analysis asks for 7 marks. So better you prepare both the analysis of coal. Now let's move to the next topic, and that is proximate analysis of coal. Well, this analysis is very important for the exam point of view. This proximate analysis gives information about practical use of coal. It involves determination of ash content, moisture content, volatile matter and fixed carbon as the weight percentage. So let's see how we can measure this moisture in measurement of moisture. Well, this represents the water content of one coal sample. It is being measured by carrying out the weighted sample of powder coal of size 200 micron in uncovered crucible. Then it is placed in oven at temperature of 108 degree plus or minus 2 degree along with the lid. This sample is then cooled to room temperature and weighted again. The loss in weight represents the moisture content. So this is how we can measure the moisture content. Here in this image you can see that one typical instrument that is being used to measure the moisture content. It contains the crucible in the shape of cylindrical or dish in the center, where we place the sample of coal and cover it with its cover. So after certain time we will get digitally on a display that how much moisture content of this particular sample is. So this was all about the measurement of moisture. Now let's move to the second analysis, and that is measurement of volatile matter. Well, it is determined by heating a known weight of moisture free coal sample in covered crucible at temperature around 950 degrees Celsius plus or minus 20 degrees Celsius for 7 minutes. Then this sample is cooled and weighted again. So the loss in percentage weight is represented by volatile matter. Here in the image on the top of the screen you can see that one cup type of arrangement, which is nothing but the crucible. It is being fixed or it is being placed inside the furnace where we can achieve such high temperature, and we are allowing all the volatile matter to get escaped. Now we weight the sample one more time so that we ultimately get idea of how much weight is being lost as the volatile matter. The methane, hydrocarbon, hydrogen, carbon dioxide are typical example of volatile matter or volatile gas present in the coal. The high percentage of volatile matter indicates that the large portion of fuel is being burned as gas. This high volatile content gives long flame and smoke. It also helps in easier ignition of fuel. This high volatile matter is desirable in coal gas manufacturing because it denotes the proportion of coal which will be converted into gas after the combustion. So this was all about the measurement of volatile matter. Now let's move to the third proximate analysis, and that is ash content. Well, coal comprises of different organic compounds that are converted in the ash through the coal burning by chemical reaction or combustion. Ash commonly include silica, alumina, iron oxide and different minerals of the lime. So this is what the composition of inorganic material in the coal. The cover from the crucible used in the last test, that is volatile matter, is now removed and the crucible is heated in Bunsen burner until all the carbon is burned and residue is weighted, which is nothing but incombustible ash. So what we do is we get the same sample that is we are using for the measurement of volatile matter and placed into the burner and allow all the carbon to get oxidized or to get burned. The residue left is nothing but the incombustible material, and that is known as the ash. Ash reduces the combustion efficiency and boiler efficiency. Well, it increases the handling cost as well. So the low amount of ash is desirable in coal sample. Now let's move to the next analysis, and that is fixed carbon. Well, in actual practice, fixed carbon or FC is determined by subtracting from the 100 the value of moisture, volatile matter and ash. Higher the fixed carbon is, greater the calorific value and better is the quality of coal. The percentage of fixed carbon can easily be determined by 100 minus moisture percentage minus volatile matter percentage and minus ash percentage. So this concludes the proximate analysis of coal sample. Here in the table you can see that typical proximate analysis of Indian coal, which includes the moisture around 5.98%, while the volatile matter in Indian coal is around 20.7%, while fixed carbon is around 34.69% and ash content of typical Indian coal is around 38.63%. So this is what all about the proximate analysis. This proximate analysis is very important for the exam point of view. It has been noticed that this question is being asked for 5 marks, or combinedly with ultimate analysis it has been asked for 7 marks sometime. So better you prepare this question very well. We will see you in next video. Till then, keep watching, keep learning. Thank you.